Okay, today I'm going to be teaching you how to solve systems using elimination. This is probably one of my favorite lessons of the year to teach. Remember I've told you that there's lots of ways of solving systems of equations. You can graph them. You can use the thing that I taught you previously called substitution. Now the third way you can learn how to do it is called elimination. And it's by far my favorite way of doing these types of problems. In fact, most of the time I'll end up doing elimination every single time. All right, so here's the idea behind this. Let's make up a problem that's true. So let's say 3 plus 1 is equal to 4. Is that true? Yes. Then let's say 7 minus 1 is equal to 6. Is that true? Yes. Now watch what happens. Let's say what would happen if I just randomly decided to start adding the columns of numbers. So I get 3 plus 7 is 10, and I get positive 1 and negative 1 makes 0. But here's the cool part. 4 plus 6 is 10. When I add the columns, I still get an answer that's true. I get 10 does equal 10. And that's true in mathematics because for a lot of reasons, but we're going to use that to our advantage right now. Because when I add columns up, I still get answers that are true, I'm going to do that with variables. For example, if I had x plus y equals 7, and I had x minus y equals 3, then if I add the columns, watch what happens. X plus x is 2x. But here's the cool thing. A positive y and a negative y makes 0. They go away, and I'm just left with 2x is equal to 10. So x has to be 5. Now think about that for a minute. Think about what we've done so far to solve systems of equations. This is by far one of the coolest ways to do it because it's so simple. I love this so much because it's really simple math. All right, and I already put this on your notes here, but if you look here on the side, look, 3 plus 4 is 7, and 6 plus a negative 4 is 2. If I add those, I get 9 plus 0 is 9. All right, so that's what we're going to do. So what we want to do first is make sure everything gets in line. Do you see how everything's in line? The x's are in line, the y's are in line, and the numbers are in line. Okay? Then what I'm going to do is I'm going to add the columns. Okay? So I get 2x plus negative 2x makes 0, plus 3y plus 5y makes 8y. And 11 plus 13 is 24. So I get 8y equals 24 because the 0 basically goes away, right? And then I divide by 8, and I get y is 3. Then all I have to do then is take that 3 and plug it into one of the equations to figure out what x is. So 2x plus 3 times 3 is equal to 11. So I get 2x plus 9 is equal to 11. So I'm going to subtract 9, and I get 2x equals 2. So x has to be 1. So that means point 1 comma 3 is where these lines cross each other. Now that is cool. That was so easy to do. It just so happens when you add 2x and negative 2x, they make 0. And so the x's go away, and all I was left with was y's, and I can solve that now. Okay? Then all I have to do is check it. Now, I just substituted into the 2x plus 3y equals 11, so I need to check it with the other one. So I need to check 1, 3. And I would just plug in the numbers. So negative 2 times 1 plus 5 times 3 should equal 13. All right? So that's negative 2 plus 15. Does that equal 13? Negative 2 plus 15 is 13. Does equal 13. It works. And that means that's my answer right here. Really cool. I love substitution. I love elimination. It's by far my favorite way of solving these problems. Okay? So let's do that again. All right, so what I want to do is make sure everything's in line. Is everything in line? Yes. So I'm going to add the columns. And when I add these columns, what do I notice? These are going to be opposites of each other. That's the key. I want the x's to be opposite or the y's to be opposite. And right now these are opposites, aren't they? And that's the whole point of what I'm trying to do. So 2x plus 4x is 6x. Negative 3y plus 3y makes 0, so it's gone. These go away. And I'm left with negative 8 plus 20, which is 12. So x has to be 2. That is so awesome how quickly you can solve those with that simple little plan. Okay? So x is 2, so then what do? Well, then I plug in the 2 to the first equation. That's 4 minus 3y equals negative 8. Subtract 4, subtract 4, I get negative 3y is equal to negative 12. So y is 4, which means 2 comma 4 is where these lines cross. Okay? And then you would check it. You would check it with this equation. I'm not going to spend the time right now in your notes, but in your own notes, you need to go over here and check it with 0.24 in the second equation. Okay? So let's do example 3. Now, don't copy this real quick. Just watch this for a minute. So if I add these columns, I get 11x minus 8y. See, these don't make 0, do they? Negative 4y plus negative 4y does not make 0. It makes negative 8y. So that's a problem because they don't make 0. But here's what I can do. I can do anything I want to one equation. Okay? So what I'm going to do is I'm going to take one of the equations, in this case the second one, and I'm going to multiply it by a negative 1. I can multiply it by anything I feel like, but I'm going to multiply it by a negative 1. Now you may be asking yourself, why a negative 1? Well, let me show you what happens. Negative 3 times 3x makes negative 3x. I'm sorry, negative 1 times 3x makes negative 3x. Negative 1 times negative 4y makes positive 4y. And negative 14 times negative 1 is positive 14. Then I'm going to write this equation right below it. Okay? So I get 8x minus 4y equals negative 4. Now, why did I multiply it by a negative 1? Look at this for a minute and tell me, can you figure out why I multiplied it by a negative 1? Hopefully, what you'll notice now is that these are going to make 0. Now these are opposites of each other, and they're going to make 0. So I get negative 3x plus 8x, which is 5x. 4y plus a negative 4y makes 0, so they're gone. And I get 10 here, so x is 2. Nice. Now that's cool because once you understand you can do that, you can start multiplying by anything you need to make them the same. Okay? So then I'm gonna put that x into the first equation. So I get 8 times 2 minus 4y should equal negative 4. So I get 16 minus 4y equals negative 4. Subtract 16. I get negative 4y equals negative 20. So y is 5, which means they cross at 2 comma 5. You would have to go over here and check it afterwards, but it does work. Okay? Let's do another example. Okay, in example 4, it's going to get a little bit trickier because what you should notice is that in this equation, the x and the y are on the same side. The x is first and the y is second. But in this equation, the x is on the wrong side. So if I was to line them up right now, this is actually would not be a good idea because when you start adding the columns, you're not getting things lined up. So that's not a good idea. So that's what I was talking about earlier. You need to make sure everything looks the same. So I want my x's first, then my y's, then my numbers. So I need to bring this 3x over. So I'm going to subtract 3x from both sides or add a negative 3x to both sides, okay? So I end up with negative 3x plus 2y equals 6. Now that's good because now watch. That's positive 3x, that's negative 3x. So when I line them up and I add them, I get negative 3x plus 2y equals 6. And I add these together. And because now they're opposites, they're going to make 0. Those go away, right? And I'm left with 4y plus 2y is 6y equals negative 6 plus 6 is 0. So y must be 0. Then I plug that number into the other equation, so I get 2 times 0 should equal 3x plus 6. Right? Well, that's 0 equals 3x plus 6. Then I'm going to subtract 6 from both sides. I get negative 6 is equal to 3x. So x is equal to negative 2. So where do these cross? These cross at negative 2 comma 0. Got it? Not too hard, right? So what was the key here? Get the x's and the y's lined up together. All right, next example. All right, so example 6. This is probably the hardest one that we're going to be doing here, because you're not going to be able to just do something simple to make them the same. Okay, so let's look at this for a minute. Right now these are opposites, but when you add them, they don't make 0. So that's not going to help me. And when I add these, they don't make 0. And even if I negatize one of them, they still wouldn't make 0. So I'm in trouble right now. So in this case, I'm going to have to do something to both equations before I can add them. So that's what I'm going to do. I'm going to take this first equation, and I'm going to look at this equation and this equation. I'm going to say, well, these are opposites. Where does 4 and 3 come together? So if you start skip counting by 4s and 3s, where do they come together? 12. So I'm going to say, what do I need to multiply 4 by to make it 12? Well, I'm going to multiply everything on the first equation by 3. And then the second equation, 3 times what makes 12? 4. So I'm going to multiply the second one by 4. Got it? Go ahead and do the math for that. When I do that math, I end up with, let's see, 12x plus 15y equals, now I was not careful here, was I? Maybe you probably already spot this, but if I multiply this side by 3, I've got to multiply everything by 3. And if I multiply the one side by 4, I've got to multiply everything by 4. So 35 times 3 is 70, 80, 90, 105. And do the second equation, that becomes negative 12x, and that's the key. Now these are opposites, see? Plus 8y equals negative 36. I'm going to add them now. 12x plus negative 12x makes 0. They're gone. 15y plus 8y is 23y. And then that becomes 9. That becomes 9, 69. Positive 69. Divide both sides by 23. And I get y is equal to 3. So what was hard about this problem? I had to look at these equations and say, how do I make them opposite? Well, I knew these were negative and that was a positive, so that's what I focused on. If I'd mess with these, I would have to multiply this one by a negative 2 and this one by a positive 5, and they would be opposites. But you'd have to negatize one of them and multiply it by something. And that's why I mess with these, because they are already opposites. One positive, one negative. Okay? I'm not done, because now I know what y is. Now I've got to solve for x. So I'm going to go back to the first equation. 4x plus 5 times 3 should equal 35. So 4x plus 15 is equal to 35. Subtract 15, subtract 15, and I get 4x is equal to 20. So x is 5. So what do they cross? 5 comma 3. That's my answer. Okay. So that is elimination, and it's my favorite way of solving algebra problems. You can get good at this really quick. It's pretty hard to mess up, and you can solve them pretty easily. It's a lot better than graphing, and it's a little bit easier than substitution. And it will probably become the one that you use more times than any others. Just remember, you're trying to make two of the numbers, or two of the variables opposites, and once they're opposites, when you add them together, they make 0. All right? Good luck with that.